In this video, I'm going to demonstrate text analysis, in particular semantic analysis using topic modeling and also using OpenAI API. Since we cannot share the interview data publicly for this study, you can use the other dataset in the GitHub repository for practice. To do a topic modeling using R, you need to first install and import a couple of packages. Here are the ones that I use in the example of the structural topic modeling, which is also called STM. You can also explore different packages. Here I'm going to import the library, and then I'm going to load the dataset that contains our text data, a brief cleanup of the dataset. So data cleaning is important. You may need to do a separate step if necessary. Then we need to pre-process the text data. Here, select the column that contains the text, which in our dataset is called spoken words. And then we do the pre-processing of removing the stop words, stemmed words, and then keep the numbers. You probably need to do a more detailed job for pre-processing for text analysis. Next, we turn the column of text into the document term matrix, which is also called DTM, that describes the frequency of terms that occur in each document. Then we select number of topics starting from a extent broad range of number. Here we started from 15 to 40. In this step, we are looking for the elbow point in the diagnostic statistics plots. You may need to adjust the range if no such pattern appears. Okay, here is the elbow point that we are looking for. So knowing that there's no single best model and the correct K-term, previous studies suggest that selecting the model that has lower residue value and higher holdout likelihood. Besides that, a desired model also need to have a high semantic coherence. You can change the code here to select the statistics that you want to show in the plot. We started with a broader range, and the topic selection process will need to illustratively narrow it down to a smaller range. So after narrowing it down to a fair point of the number of topics, we want to take a closer look at the coherence versus exclusivity. Here we plot three values, 25, 30, and 35 topics. So previous studies suggest that a smaller K tend to produce a high semantic coherence, but with probably two general topics that it perform poorly on exclusivity. Here we are looking for the number of topics that gather together at the top right corner as much as possible. If you could not find a clearly best choice in this plot, you may need to manually inspect some sample topics and some sample documents for this model. So after selecting the number of topic K, in this case, we decide to go with the 30 topics. If we are using a sample data provided in the GitHub, you may end up with a different number of topics based on how many rows that you included in this analysis. We now take a closer look at our results. So here is the top words for each topics. You can also visualize the topic proportion. here. This is the visualization of topic proportion. You can make this plot larger so you can see the words. And then the coherence, the convergence among each topics. And since our interview is designed to cover several broader topics, so it's expected to see some topics that fall into the same area. And then you can also choose a topics. Here we choose topic number 27 to do a cloud word to further visualize what's going on inside this single topic. Then after getting this 30 topics topic model, we use this topic to proceed to a next exploration step. We can use the STM browser here to further inspect each documents of the topic modeling. Or you can also manually download and check the topics and their topic proportion. So also feel free, when you label the topic, it's totally normal to remove some topic from your modeling because you cannot give them a coherent label. So if you select you select the model of 30 topics and you could only label 27 topics and need to remove 3 topics, that's totally normal. And you should not feel the pressure to find the appropriate label for all the topics. Besides, to validate the label, it is common practice to invite people who are not involved in the process of topic modeling, but have the background knowledge necessary to do the validation for the topic label. After validation, we are able to produce a codebook of 25 child code with a corresponding parent code in a various area within the scope of education policy and practice. We then use the codebook to ask ChatGPT, ask the OpenAI API to label the same set of text data to compare the results of traditional natural language processing models and large language models. Now I'm going to show you how to use OpenAI API to do the text analysis. So in order to use the OpenAI API to do text analysis, you need the API key, which we have already pre-installed here. And then you need to install the OpenAI library and then load it. We already preload our package here. So if you do not have OpenAI API key, you can also use ChatGPT to do this practice. So here is an example of how our text data looks like. And there is an example of our codebook. So here is the child code, parent code, and we also give a brief description of the child code and some keywords for the child code. This is the output from previous topic modeling step. Then we build a function for interacting with the OpenAI API. Here is our function. So you can change the parameter here to use different for different type of tasks. And then you can, here we choose the GPT-4 model. You can also choose the 3.5 model. We attempt 2 types of prompts here. So the ultimate goal here is to get 3 most salient child code level theme for a given paragraph. And the first prompt is the 0-shot prompt, which is the prompt that you are seeing now here. Which means we input all the requirements to GPT and ask it to output all the results at once. In this case, we ask GPT to dive into child code and child code description, select three most salient themes for a given paragraph at the child code level. Only when GPT cannot identify a child code level code, because the paragraph probably is too broad or too vague, it is okay to select from parent code or return none. Here, we provide the entire codebook, one paragraph at a time. We receive three child code themes and a brief reasoning from the GPT as the results. Here, I'm going to show you. Here is our results from GPT. You see the three child code level code and then a brief reasoning here. Well, the second prompt is the chain of thought prompt, which means we input requirements step by step. In our case, we ask GPT look at the parent code first, which is at a broader semantic level, and select three most salient parent code. Then at step 2, from the parent code, GPT is asked to further narrow down to child code level, selecting the most salient child code under each selected parent code. Then do a brief reflection on the selected pair of parent-child code and drop the one that do not fit well, and select three pairs as the final results here. So the input for these two prompts are the same, but the structure of the output is slightly different. Here is the output. Oh, it takes a bit longer. Yeah, so here is the output of chain of thought prompt. So from this prompt, we receive the parent code and its corresponding child code. So we receive the three paired codes, and then we receive a brief reasoning from the GPT. So as for prompt design, in addition to domain knowledge, for example, the definition that the child code description that we provided in the codebook, and also the codes that we provided from the codebook to GPT, some features such as clear and detailed instructions of the tasks and output, mark the keywords using coherent description for the same items throughout the prompt, are also very important for obtaining these desirable results. So now we compare the zero-shot results, the chain of thoughts results, and the topic modeling results. We see the similarity exists among these analyses, and the difference also exists. So here ends my demo for the text analysis using topic modeling and the OpenAI API.